Good day, students. On this clip, we're going to be going over two examples on how to use the law of sines. Okay, so let's go ahead and write down the instruction for the examples. So we are to solve the, the triangles or the given triangles. Solve the given triangles and round your answers. Round your answers to the nearest hundredths. Okay. Now to solve basically means we have to find all the measures that are not given. That's what solving a triangle means. So for question number one, we have a triangle with measures angle A equals 30 degrees, angle B equals 50 degrees, and side length B equals 30. Alright? Okay, so we're going to go ahead and solve this. We have capital A, capital B, and little b, so we need to find little a, capital C, and little c. Alright? So first thing we want to do is we want to draw a triangle. We're going to draw a scaling triangle and populate it with the measures that we're provided with. Okay, so let's draw a triangle for ourselves. Draw a triangle of this nature. Now the way this triangle is labeled is extremely important. Okay, you have to make sure that similar letters are opposite each other. Okay, so capital letters represents the angles, and then the small letters represent the sides. Okay, so if I call this capital A, this angle is capital A, 30 degrees. You put the degrees on the inside, and that automatically means the side opposite it is side length A. Okay, side length A, we do not know, with a question mark. Alright, and then capital B represents this angle. You put the measure on the inside, 50 degrees. And take that out of there. It's 50 degrees. And then side length B is 30. We know that. And then for C, this is capital C. We do not know what this measure is. Neither do we know what this measure is. This side opposite angle C is side C, and we do not know what the measure is. Okay? So to solve this triangle basically means we have to find the value of little c, little a, and big C. Alright, so first of all, ask yourselves which side or angle is the easiest to find. If you think about elementary geometry, it's easy to find the third side of the interior angle of a triangle given two angles, right? So we're going to find the angle first. So let's find angle C. Okay, what we're using is called the triangle angle sum theorem, which tells you that the sum of angles in a triangle is 180 degrees. Alright, so to find big C, all we just simply do is subtract the sum of all the angles, which is 180, from these two angles that we know, 180 minus 30 plus 50. Okay, if we do the arithmetic, we'll have angle C equals 180 minus 80, and that tells me that angle C is 100 degrees. Okay, so angle C right here is 100 degrees. Scratch that out. Okay, good. We have one piece of information. Now let's go ahead and find the other two. Now the other two are not as easy as this to find. We have to make use of trigonometric tools to figure them out. Alright, so what do we want to find next? We can find little a or little c. In order to find any of these, since I have one pair angle on the side that I know, then I can automatically use the law of sines. Okay, we know what the law of sines are. Law of sines, we have, it is a over sine A equals b over sine B equals c over sine C. We use two at a time, or another variation of this is sine A over A equals sine B over B equals sine C over C. They basically mean the same thing. All right. So what are we looking for? How about we look for A first? Okay. So let's find A. Okay. So if we want to find A, I'm going to start out my formula by writing what I'm looking for, which is A. I'm going to write A over sine of the angle opposite A, which is A. Now this is a ratio that's the pair that I'm missing a measure, namely A. So the next pair I have to pick, I must know the side and the angle. Okay, I must know the pair both sides. So that's why I said since we have a pair that we know here, we can use the law of sines because it's required. So since I know B, big B and little b, the formula I'm going to use is A over sine A equals little b over sine big B. Okay? Alright, when I substitute, I must have only one unknown in my equation, or else I can't solve it. So let's go ahead and make a substitution. Little a is unknown over sine, angle A is 30 degrees, equals little b is 30 over sine, big B is 50. Okay? Can I solve this equation? Absolutely, because I have one equation and one unknown. Alright? So how do I solve this equation for little a? I need to get rid of this denominator. So I multiply both sides by sine 30. Multiply this by sine 30. Multiply this by sine 30. Please divide out. And your answer is going to be a equals 30 sine 30 divided by sine 50. Okay, so we're going to plug that into our calculators to get our approximate result. So let's bring out our calculators. Make sure that our mode is set to degrees. Let me go ahead and fix that real quick because our angular measures are in degrees in this problem. So we're going to do parentheses 30 sine 30, close that, divided by sine 50. I have only one argument in the denominator, so I'm going to put parentheses. Enter 19.58 to 2 decimal places, so it's approximately 19.58. So little a is approximately 19.58. Alright, let's go ahead and look for the last side, which is little b. So let's find, partition my works, scroll down. Let's go ahead and find little b. Actually, I know what little b is. I need to find little c. Okay, so to find little c, let me set up the equation first. So to find little c, I'm going to use law of sines again. I'm going to go little c, which is what I'm looking for. I like to write what I'm looking for first, over sine big C equals, now I have two choices. Since I know little a and big A, I can use that. Since I know little a and big A, I can also use little b and big B. But the problem with little a is an approximation, so our answers won't be too accurate. Besides, it could be wrong also. So it's safer for me to use little b and big B since I was given that in the problem. So I know for sure that it's going to be accurate and they're exact values too. So it's smarter for us to use little b over sine big B. Okay? So that's what I'm going to use here. Alright. With that in mind, let's make our substitution. We should have only one unknown in this since we have one equation. Little c, we do not know what it is, over sine big C is sine 100. That was the first answer we found. Equals little b, which is 30, over sine 50. Okay? Now to get big C by itself, you multiply both sides by sine 100 so that you can get rid of this denominator here. Sine 100. So this divide out. And then you have C equals 30 sine 100 over sine 150. sine 50. Okay. All right. Now we're gonna plug that into our calculators to generate our approximate value measure for side C. All right. So let's plug that in. So we have let's put in parentheses 30 sine 100 plus the sine argument plus the numerator divided by sine 50. Okay. And then your final answer, we're going to write 38.57 to 2 decimal places. So C is approximately 38.57. All right, so there you have it. Okay, so let's organize all our answers in a list so that we make sure we have everything down. So for this problem, we have spread solutions. We have big C equals 100 degrees. Little c is approximately, let's try that again. Little c is approximately 38.57, and little a is approximately 19.58. All right, so there goes your answers. All right, let's move on to question number 2. All right, for number 2 is exactly the same instructions. We're going to solve a triangle with the given measures. So let's write down the measures. So for number 2, we have angle A is 65 degrees. Angle B, big B, is 50 degrees. And angle C is 12. All right, so let's go ahead and make a sketch of the situation so we can label our triangles correctly and set up our formulas accurately also. All right, so let me draw myself a triangle of this nature. It's not perfect, it's just a sketch. Angle A, let's call this angle A. 65. Remember, the little letter goes opposite the big one, so this is big A, this is little a right here. I don't know what that is. Let's call this angle B, and angle B is 50 degrees. So this is angle B, the side opposite angle B has to be little b, okay? And then this is angle C, I don't know what that is. Side opposite angle angle C is little c. We know that that's 12 units long, all right? So we can see in this problem we need to find little a, little b, and big C. All right, so what can we find first? The easiest thing to find is angle C using the triangle angle sum theorem. We cannot even use the law of sines here because we do not have a pair that we know. Okay, see this pair, we don't know both of them. We don't know both of these, and we don't know both of these, so we can't even use law of sines. So the only thing we can find first of all is angle C using elementary geometrical tools. Okay, so let's find big C first. So to find big C, we know that the sum of angles equals 180, so C is simply 180 minus the sum of the other two, which is 65 plus 50. Okay, and then when we do the math, the arithmetic, will have C equals 180 minus 115. When you subtract the 2, you have 65 degrees. Okay, so angle C equals 65 degrees. So there goes the measure of angle C. All right, now we can start figuring out the measures of the sides. Put that there, 65. Okay, so we can either figure out A or B first. It doesn't really matter. How about we figure out side A? Okay, so let's find A. So to find A, we're going to use law of sines. Well, why can we use law of sines now? We can use law of sines now because we have a pair, a side measure of a side and the angle opposite the side. So we can use law of sines to find the missing side. So I like to set it up using what I do not know first. So it's a. So I'm gonna write a over sine a equals. Now the next ratio I must know the pair. Okay. So which is c and big C. Little c over sine big C. Okay. Now let's make a substitution. I must have only one unknown in my equation or else I can't solve it. Alright, so little a I do not know over big A is 65 over sine 65 equals little c, which is 12, over sine big C, which I just found as 65. Okay? Alright. Alright, so to get little a by itself, I will multiply both sides by sine 65. And 65, so this divides out, and then that yields a equals 12 sine 65 over sine 65. Okay? We don't need a calculator to do this because you notice that the sine expressions are identical, so we can just divide them out. So sine 65 goes here once, sine 65 goes here once. The final answer A equals 12. Alright, so there goes the measure of one side. Now we need to find the other side, namely little b. So let's go ahead and do that. So we're going to find little b. Okay, alright, so to do that, we are going to use the law of sines again because we have a pair that we know. So I like to start off with what I do not know, which is little b. So little b over sine b equals, now the next pair I select, I have to know it, the big and the small. Okay, so let's see, we can use a or b, we can use a or c. They are both nice figures, they haven't been approximated, but since this is part of the original question, let me just use c. Okay, so I'm going to use big C and little c, so over little c divided by sine big C. Okay, so let's make the substitutions. Now we have little b over sine big B. Sine big B is, let's see what sine big B is. Big B is 50 degrees, so sine 50 equals, little c is 12 over sine 65. Alright, so to isolate little b, we'll multiply both sides by sine 50. Sine 50, sine 50. So that gives us little b equals 12 sine 50 over sine 65. Okay? Alright, so we just plug that into our calculators, and that will give us our answer. We'll round it to 2 decimal places. So let's do it. We'll have parenthesis 12 sine 50. Close that, divided by sine 65. Final answer is 10.14. So our answer here is going to be 10.14 to 2 decimal places. So B is approximately 10.14. Alright, so let's go ahead and organize all our 3 results in a nice list. So our solutions are big C is equal to 65 degrees. Little c is equal to little a is equal to 12, and little b is equal to, well, actually little b is an approximate result, so little b is approximately 10.14. So there you have it. Thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking subscribe up here. And please post a comment to tell me what you think about this presentation. More clips can be found on MacGuardServe.com. Thanks again and have a wonderful day.